Let's talk about a rectified AC to DC voltage. And we're going to calculate the DC voltage. Now the DC voltage is equal to the peak value minus the DC ripple voltage for the RC filter. Okay, so we're going to start off with 10 volts RMS AC voltage here coming out of the transformer. It's going to go through a bridge rectifier, into a smoothing capacitor, and into the load here. And we're going to calculate the DC voltage we're going to get on this point here. Now, that's going to be to our peak value, okay, and our peak is going to be 1.414 times the RMS. So for 10 volts, it's going to be 14.14 volts, okay? And then we're going to subtract the ripple voltage here, and the ripple is equal to the peak value times the time that the capacitor has to discharge just from here to here, and divided by 2 times RC, okay? Now, this time here, for 60 hertz, that's 1/120th of a second, okay? So it's going to be 0.0083 seconds, okay? So we have 0.0083 seconds. Our VP is going to be 14.14, and then our capacitor is going to be a 100 microfarad capacitor, and we're going to have a 1K resistor here. So if we do the calculation, we take our 14.4 and we're going to subtract the ripple voltage over here. So we multiply this out, and that comes out to it'll come out to 0.5868 volts, okay? And we subtract that from our peak value of 14.4, so that means that our DC voltage is going to be 13.55 volts out here. Now we're going to have a drop across the diode here, and it could be 1.4 volts. So that means that our DC voltage out here is going to be about 12 volts, okay? And we'll set this up, and we'll see if what we're going to get out of there. We're going to measure the AC voltage, the AC current, the DC current, and the DC voltage. So here it is here. This is going to be in current, milliamps, and this one's going to be milliamps, and this is going to be voltage, AC voltage. So this one's AC. We've got to change the range on here to AC. There we go. So let's see if we can see that. All right, so well, we have 10 volts, and this is our current here, or milliamps. We have 13 milliamps going into the AC, but coming out here we have 11.9 milliamps. We're taking into a 100 ohm 1K resistor, and then our voltage is going to be 11.9 volts. We had calculated 12 volts, but I'm sure I have some other losses in here that we're not looking at here, but so that's pretty good. We started off with 10 volts AC RMS, and we ended up with, say, 12 volt, close to 12 volts out here. Now, say we want to have 9 volts out. We want to use 9 volts. So let's bring this down to somewhere around 7 volts or so. We would get out. Oh, that's 8 volts. So it's hard to adjust it here, but anyway. Now, if I use a bigger capacitor on here, I can get more voltage out of it. So now let's go up to 20 volts. I have to turn that up. We got 25 volts coming out. We go to 24 volts AC coming in, and we're going to get 30 volts DC on the output, 30 milliamps. So yeah, so that's how you do how you calculate the DC voltage. So if we're putting in 24 volts AC, we're going to get out 30 volts DC here. Now, if I change the capacitor here, we can change that around because we're going to change our RC time constant there. But that's how you convert AC to DC. Thank you.